where your a value is not equal to 1. Believe it or not, we could have done it yesterday, but I think after the fact that we kind of had a little bit of a flubub, shall we say, when it came to the quiz, try to not put too much on you right off the bat, I thought to make it go this way. Sir. There's a couple on the ledge here on yourself. And what I want you to look at, whenever you're worried about, whenever you're worried about completing the square, when your first term is not equal to 1. Since this is an equation, what could you do? Yes, sir. Yeah. All you ever have to do, sharpen it back. All you ever have to do when your first term is not equal to 1 is you always delete. You always divide everything by whatever your a value is, no matter what it is. If it's a term, in this case, it is a common factor, but sometimes it's not going to be.
Just to make our life harder.
That's it. That's it.
Are we turning in homework?
We're going to add to it today. I'm going to add some more stuff to it today. So all you got to do really is just divide everything out, in this case, by -3. You got x squared minus 8x is -9.
Wait, is this going to be part of the homework? Because it's 156?
I don't know. I haven't decided what the problems are giving you
I
yet.
don't know if I should put it on my homework page or my notes page.
I'd go on note page.
Thanks, Brayden.
So now what do you do? Same thing we've been doing. It's kind of nice when you have the same thing over and over again, isn't it? What we will come up with today is a method to decide when to do what. And I'm going to show you guys a really easy way to do this. Half of b is how much? Where does the -4 drop? When you square a -4, what do you get? And what's -9 and 16? I don't know why you had to get ready for something. I couldn't figure that out. And now what do you do?
Add 4.
What do you
After you square root. I was working ahead.
That's all right. Just want to make sure you. And we always do plus or minus for our root.
And then you add 4. So you get x equals 4 plus or minus root 7.
You're gonna be okay. You're gonna be okay. Oh.
Curl your toes.
Curl your toes. Curl your toes.
You're curling it.
Yes, sir.
My shoes off.
The worst that can happen is your grass lights on fire.
The worst that can happen is I show.
Yes.
I show kids. Like, no, I already bought the stuff. He has to come now.
Squeeze, relax, curl toe. Okay? Don't hyperventilate. Do I need to get you a paper bag? Okay. So, really, in all honesty, guys, as we go through a lot of these things, what I want you guys to see what do you do now? Bless you.
Oh my god.
What is it? No.
Multiply by 4.
Well, think about what do you think you should do? If you think about what we did a second ago, we divided out the leading term coefficient. In this case, the leading term coefficient is 1/24. Exactly. So in this case here, I am still dividing by the 1/24, but when you divide by a fraction, what in essence are you doing? Multiplying by its reciprocal. Okay? So what you wind up doing here in a case like this, you're still going to multiply everything or you're gonna divide by this fraction. So divide everything by 1/24 is the same thing as multiplying everything by 24. And then it simplifies itself through because you're doing the same thing to both sides of an equal sign. So I still get 0 times 24 is
0.
so you're all right. So you get x squared minus 12x, and then let's see, what would that be? 4 times 13 is what? 52. And you go from there. Does that make sense? That's about as goofy as any of these things are going to work out. We're going to see stuff like that, like I said, later on when we go through the conic stuff. Because what will happen, actually I can show you this real quick on your calculator. If you go to your calculator real quick, and you hit the button that says apps, there's a bunch of pre-installed apps on these calculators. One of which is called Conic. No, Tetris isn't on here. Believe me, I had Breakout on mine. Remember that one where the ball would drop and you have to bounce it up?
Yeah?
I had that on mine for a long time. But it was
How
so...
do you get it on?
You download it. Some kid in my high school was a nerd. A really smart kid, sorry. And he was able to program it, and then you know how these things have cords to talk to each other? He just set the program to the calculator and sat there in calculus. Hit
That
button.
seems awesome.
Hit button number 4. Option 4 says conics. And then I want you guys to look at hyperbola, number 3. Now, what these equations are, these are generic form of equation of what we're going to look at in a couple of weeks. And I want you to see that there's a lot of junk squared terms. We do a ton of completing the square in this section to get this junk squared parts. So that way we're going to be able to find centers of conic sections. We'll be able to find out where the vertices lie. Things like that. It is very simple, and as you guys can see, that by using these fractional things, we're going to keep using the same basic principles throughout the next couple of weeks, okay? Just to give you guys an idea of what we're going to be able to use this with, all right? So if we go back to this one now, we're at this 52. I'm sorry, 52.
Oh.
I know it bounces.
That's cool.
What times what's 52? You got to get negative 12. Can you think of anything? No. So I'm going to subtract 52.
No.
And like I was saying a second ago about the ideas of when to use what method. Do I want to try to factor? Do I want to take completing the square? Do I want to graph it? If I can't answer the question, what times what's 52 that adds together to get negative 12 in about 15 seconds, knowing that my B value is even, it's a prime candidate to use by completing the square because half of 12 is 6. It's very, very easy to work with, okay?
It always takes me at least 15 seconds. Even if it's like negative 9x and like positive 8.
Oh, and that's okay, but the idea is anytime that your middle term, your value of B is even, it's always a good idea that you can complete the square. It's a method that will work without having to worry about fractions and all that other junk. So we have half of B here is negative, so negative 12 over 2 is negative 6. Drops to our parentheses, square it, and we get a 36. Add that together, what is that? Negative 16, I think?
Yeah.
So we have negative 16. So what's the square root of negative 16?
4i.
Plus or minus 4.
Plus or minus 4i. So we have x equals 6 plus or minus 4i. Now, does that mean it's 10i and negative 2i?
No,
Why?
because 4i is different than 6.
Correct. I'll take that. Treat it just like you would combine like terms. You can't combine those two, okay? You can't combine those two.
What is this calculator thing?
What thing?
The thing that you're just showing us?
Oh, I'm just showing you that the generic form of the equations of conic sections write things out into junk squared. And how do you make junk squared a lot of times? We complete the square. Basically, what's going to happen here in a few weeks is that we're going to be able to do something like this. we're going to be able to take that. We'll be able to take this and complete the square twice and find out what kind of a conic it is.
Can't you just, oh, shoot.
Okay. We'll be able to take this. What we would wind up doing is just
You
group.
just combine the like terms.
Yeah, you group the x's together. You group the y's together.
It's so annoying. Why are there two combinations? So annoying.
What's that?
Why are there two combinations? Why is there
Joey, I feel really bad for you today.
I am.
You're gonna be okay. I promise you, this all works out. Seriously, it works out. All right, and I'm going to make sure you remember this.
Sunday, October 2nd is going to be the best day of my life. You're the best. I'll make you a sign over
See, now you know it will work out, and you know this now.
What is it? What even is it?
It will work out. So, like I said, this is kind of where we're going to head to eventually. It is actually really simple. It's just the same idea of completing the square on multiple occasions. All right, so that's what we're getting towards. So, like I was saying, when do you factor versus complete the square? You can always complete the square if you want, absolutely. No, but my only concern about factor versus complete the square is that I would complete the square when b is even.
because then you don't have fractions.
Because then you don't have fractions. That's my personal thought. If b is even, I'll complete the square. Yes, sir.
Also, if the equation is 0.
Right, well, yeah, you can do that because we only complete the square when we're solving for zeros. Okay, so we worry about things when we solve for zeros. So factor, if you can think of the terms quickly, go for it. And then complete the square, you're right, you can always default to complete the square because it's always going to work. And there's nothing wrong with that. My only preference is that b should normally, it's easier to work with when it's even. Okay? That's my idea. Now, what about the quadratic formula? When do you use that? Do you remember the quadratic formula?
Yeah.
What is it? Do you remember the song?
We didn't learn this one. It's
Wait, isn't it?
square root
4a.
4a.
Are you going to show us the video?
I have to find it. I'll have to find it. Which means I should probably give you guys, every year I give you guys the option to create a quadratic formula original song. And yeah, but I like to have you guys record it, throw it on YouTube and email it to us so we can make fun of you. And it's usually I throw a couple of points your way for that. Yes, sir?
I heard like
I'll do
nobody
it.
laughed.
What's that?
I heard nobody laughed when they did.
Because theirs was on their driveway, wasn't it? I thought, yeah, I thought it was hysterical.
Let's do it.
But let's see here. What's today's date? Today's Tuesday. Since we're going to be working through this stuff probably through the middle of next week without too much of an issue, why don't we say this? I'm going to talk a little bit about quadratic formula today. That way it's out there in case you ever want to use it, because it's one of those other methods to factor and finding zeros. Today is the 27th. We have a full week next week?
Probably. What?
Yes. Oh, that's right. Friday, we're off Friday. Is Thursday a full day?
No, I think
6th?
Thursday's a half.
No, it's the first.
Wait, it's Thursday. Oh.
Is Thursday a half day though?
No,
I think it's the I think you're right. I think it's the second. I think it's the second.
like this Sunday.
Okay. Let's do this. Okay. So what I'll do. All right, this weekend's homecoming because you guys will probably not want to do anything.
Nope.
It will be okay. And then that's Columbus Day, right? 10th?
Yeah.
Oh, I'm giving you guys a lot of time then. Okay.
After October 1st, I will be a sane person again.
Sure about
I will
that?
be myself. She's never sane.
So let's do this then. How about this? This will give you, because you guys are right. This weekend's homecoming. You guys will probably be busy. There's stuff going on.
So you won't give us homework over the weekend?
Sorry, I just thought of something really funny.
Thanks, Alan. Nice job.
Should we shoot for the 11th?
Something really
We'll
funny.
make it do when we come back from Columbus Day weekend.
What?
If you want to do a song collaboration, I don't want groups of people more than like 4. No. Hey guys, it needs to be an original because you can Google quadratic formula songs and people all do these crazy things and stuff like that. Be an original version of it, an original, I don't know, skits, whatever. Try not to make it longer than 3-4 minutes tops, but have something fun, have fun with it. And, you know, I've generally done a couple extra points your way for doing so. We'll make it do the Tuesday we get back from Columbus Day weekend. So that would be the 11th. That gives you 2 weeks to work on it. Yes. Because then, obviously, because this weekend is, because this weekend's a wash because of a homecoming. The following weekend, you got a 4-day weekend. That would have been. Yeah, Trav.
How many points will it be?
You know, usually I throw like 5 or 6 points on a quiz grade, so it's a good little chunk
5.
on your quiz grade. So it's a 35%.
At least
bump.
15.
You can. I cannot sign it.
15 on the test.
Trap, shut up. I'm trying.
Yeah, trap. Yeah, trap. Yeah, trap.
We will miss you.
Like Friday, like
That's cool. That's fine. We'll get caught. Everything will be online. No worries. Yes, ma'am.
Seriously, 6 points to get made fun of it.
With 12th hour?
I wanted to.
Yeah, that's fine.
So hard. So
Yeah, if you have no friends in here, joking. And you want to work with people in 12th hour, I don't know why you want to work those yahoos. By all means, you guys can collaborate. It's okay. But try to keep it within 4 people in a group. I don't want to do, because then it's just, you get more than 4 people in a group, then 3 people are not doing any work and 1 person's doing all the work. So. Does that seem fair?
I want to say no matter how super I wish there was like a wall where it wouldn't bounce. Like you just throw this.
credit.
I would throw this at you. At someone.
Quick credit.
All right, real fast, quadratic formula. So quadratic formula is the last way that we can set up to solve and factor problems. When you set up the factor problems via the quadratic formula, you once again are guys, you're just using coefficients. You have A, B's, and C's here, okay? Quadratic formula gives you zeros for your x when x equals negative b plus or minus square root b squared minus 4ac all over 2a.
Hey, dude, you just stole my song.
Hey, dude?
Yeah, dude, that's my song.
Dude? Do I look like dude?
Yeah.
The dude doesn't abide by that.
That was my song. You just stole it.
Oh, just get over it.
All over 2a.
Quadratic formula, I know all you guys have done that
That's my
before.
song.
All you're doing is plucking coefficients. It's another means to solve and get zeros. It works for imaginary, it works for real, it works for for one solution, two solution, all that kind of stuff. I'm not going to get too involved with discriminant today. I just wanted to throw this out there to give you guys another option for factoring. Okay? So when we're doing all these things, when do you think quadratic formula is a good one to use? When you can't use the other ones. Good. If you can't factor something, if b is not even, if b is odd, if your leading term, if your first term is not equal to 1 and it's not factorable, and you don't want to divide
So
everything
3.
out, yeah, it could be 3. It could be 7, I don't know. It could be negative 12. Sir.
I found it.
Oh, okay. We'll show it later. But basically, guys, when it comes down to the three methods, factoring, if it's quick and easy to go through, complete the square when b is even, and leading term is 1. Quadratic formula when all else fails. I will say one thing, you've got to be careful when you're doing this one, not to put everything in your calculator at one time. What I would do with the quadratic formula is I would figure out these values first, put it in the square root, and then go from there. Be careful, remember how to check for simplifying square roots, because you have to do that as well. Remember, you throw that in the y equals table. Remember how to do that? Like 112 over x squared, and look for your values. So those are your three methods for factoring, really.
Are we going to get our quizzes back?
I have a couple left to go through, so probably, I don't know, maybe tomorrow. That'd be my best guess, okay? So let's do this then. As far as homework stuff that I'd like to look at for today, we have this chunk down here. Solve by any means necessary. And I think it's a good idea that you now have all three methods. So why not do those 10? Add them to it, okay? You can pick whatever method you want. Yeah, I'll throw these up here.
63. Quadratic formula takes too long.
It does. But it's another method that works. It's another method that works, there's nothing wrong with it. Quadratic, it's the same page, right? The same one. It's whatever one was yesterday, I forgot.
I think
Right.
it's 287. Wait, what numbers? I can do this. 72.
Alright, so you've got, so if I'm looking at this very first one, x squared plus 4x minus 12. First thing I do, what times what's negative 12 to add together to get 4? 6 and negative 2. So if I can think of that real quick, why not? Because if you go through and complete the square on that one, you just got to be careful. You're going to get x squared plus 4x. Hey, buddy. Plus something is 12. 4 over 2 is 2. X plus 2 squared, 4. So you have x equals negative 2 plus or minus 4. You got it right. When you get to this part here and you get two values that are integers, ones that you can add and subtract together, write them both out. So that's one thing that people will forget. So negative 2 and 4 is 2. Negative 2 and negative 4 is negative 6.
Oh, that's not what I got. Oh, yes, that is exactly what I got.
Because you factored it like this and you left it. Because it's an equals 0, you got to go 2.
No, that's not what I did. I just put 6 and 4.
It's just easier to
I mean,
do the first
instead of
way.
2 and 6.
Gotcha. Okay? You got the different methods to go for it. It's totally up to you which one you choose to do. I am not going to yell at you.
How many?
Maybe. Yes, ma'am.
For number 65, what would you do? Because there's no, like, x
What would you do?
square root. No, divide by 9.
What would you do first?
Oh, add 23.
And then what?
Divide by 9.
And then what?
Square root.
There you go.
Okay, I forget that.
And you just work yourself backwards like you would solve it before.
Why is 23? So unnecessary. This book couldn't make it like 27, they had to make it 23. You divided by 9.
Well, the new book hasn't even introduced you guys to the imaginary numbers yet. They go through all the factoring, and then at the very end, they show you how to do imaginary number, and they don't do any factoring with imaginary numbers. What a disservice.
Wow, the old book rocks. Yeah, can you just use that book instead?
We do a lot. I will.
23 over
Intermittent.
9 is not able to, it's not simplified.